Hello, I'm Ron Shook, and today I'm here to tell you how we prepare agarose gel for gel electrophoresis at our school. So one of the things that I did is I determined the volume of our gel electrophoresis tray, and I'm just going to prepare that right now with some tape. I just have a masking tape here, and you want to make sure that you're getting your tape in around the edges here so gel doesn't leak in underneath. It's a little easier to do that for me with the tape down on the table. And I'll get that aimed up. And now we're looking at something like this. There we go. And now I'll just push down on that. We want to make sure we bring that edge around. That's where leaks will sneak through. So we want a little overlap here to the bottom to make sure we're not going to leak. And then we'll just repeat that process on this other side here. So you can also aim it up this way. And then come over and fold over on the edges. Either way, we're going to end up with something like this. I'm going to make a gel that is about 100 microliters in volume. And I have an Erlenmeyer flask here that I will use to prepare things. I have my buffer, and it is a 10 times solution, so I'm going to dilute that down by mixing 10 milliliters of that with 90 milliliters of distilled water. Comes the distilled water. We've got buffer, and then it will be time to measure out the proper amount of agarose. So when we prepare a petri dish or a plate for growing bacteria, we use a substance called agar. It's important to understand that that is a different substance than what we're doing today. We're using a substance called agarose, and that is used to make gels that are useful in gel electrophoresis. So I've zeroed my scale with my weigh boat. I have the agarose powder here. I want to make a 2% solution, so for my 100 milliliter volume, that will imply 2 grams of agarose. So we're going to weigh that out. And we're going to be pretty close here on this one. And there we go. We've got 2 grams. Since I already have my 1% TBE buffer ready, I will take the agarose, and we are just simply going to pour the agarose in to the buffer and give it one swirly whirly, and it will be off to the microwave oven. So we're basically done now with a 45-second run in a microwave oven of our 1% agarose solution. I'm going to take this out, and we're going to swirl this around. And when this is ready, our solution will be quite clear. And as you can see right now, we're still a little bit on the foggy side. So I'm going to put this back in the microwave, and we'll see what another 15 seconds does for us. And sure enough, we're in a position right now where we've cleared up that solution significantly. And I think we're ready to let this cool on a countertop. And most science countertops are made to withstand some heat. And just by leaving that on the countertop, the heat will be conducted to the countertop, and this will cool down. And when it's cool enough to touch without feeling like you have to take your hands off it right away, we'll be ready to put in a little gel green stain is what we use here at the high school, and then we'll be ready to pour our gel. So I have here with me a product called Gel Green, and it serves the purposes for gel electrophoresis of helping DNA show up on the gel, and it's a nice one for high school because it's relatively safe and effective as well. So for our recipe of 100 milliliters of solution, 10 microliters of gel green is going to be what we need. So I've got my pipetter. We'll get the gel green. I like to touch it to the surface of the gel. That will just help it distribute and be released from the pipette tip. I don't have my hot glove on now because I've been checking the bottle, the Erlenmeyer flask, and I can hold this for a few seconds without my hand feeling particularly uncomfortable. We'll do another swirly whirly, cap my gel green, and at this point we are ready to pour. So we'll just slide over our tray, and here we go. So I'm getting a pretty good pour out of this. Sometimes what will happen is there will be a few bubbles, and then either with it attached to a pipette or just grabbing a pipette tip, you can either pop bubbles or maneuver them toward the edges of your gel. Just clear those right on out of there. And the last thing is to grab our comb. For my class, I've chosen a 15-well comb. Your decisions are generally based by how many samples you want to run. And there are some little pieces of the comb that are designed to be able to fit in on our mold. Sometimes the molds stretch a wee bit with the increased temperature. But that comb is extending down into the gel, and when the gel solidifies, I'll remove that comb and I will have the 15 welds that I would like to have to run our PCR product through gel electrophoresis. Thank you so much for listening, and happy electrophoresing.